Truss Council of America, in association with the Building Systems Council of the National Association of Home Builders, presents Framing the American Dream. This educational demonstration project took place at the 1996 Builder Show in Houston, Texas. Two identical houses were completely framed at the same time using different construction techniques. The purpose was to compare the costs and the efficiencies of component construction and stick framing. Final calculations showed that the component-framed house required 253 fewer man-hours and saved more than $3,300 compared to the stick-frame version. Here's how it happened. Computer-aided design and engineering assure accuracy and structural integrity in the manufacture of components. Factory production lines take advantage of automation and computer controls to produce components of the highest quality. Fast installation of floor, wall, and roof components shortens field construction time, allowing a building to be closed in quickly. That means less potential weather-related damage to building materials or delays that could increase interest charges on construction financing. Components take less skilled labor to install. With a good set of layout drawings, the building goes together almost as easy as connecting the dots. There's less job site theft, too. It's not easy to walk off with components for a home repair project. And with component construction, there's less waste produced at the job site. With conventional joist framing, each joist must be inspected and properly crowned, then typically spaced 16 inches on center. Trusses are supplied in long lengths and spaced 24 inches on center, speeding the setting process. Open web floor trusses allow easy access for ducts, pipes, and wires. This attic frame truss spans from wall to wall. There's no need for interior bearing walls below the truss. Clear spans provide great design flexibility in interior planning and partitioning. Any truss profile can be created. The only limit is one's imagination. Now let's get into the details of framing the American dream. Every project begins with a good set of plans. Good planning up front will minimize problems on the job site. For framing the American dream, good sets of plans were provided to both framing crews so they would know exactly how to put each structure together. Component shipments come with framing plans for fast, efficient installation of each component piece. It is very rare to find a perfect set of plans. That's why component manufacturers use computers and engineering to work out any problems before the components get to the job site. Computer-aided design assures that the structure will perform as expected. All loads are accounted for and get to the proper location on the foundation. The building can even be engineered to optimize lumber use, saving money, and a valuable resource. Buildings can be viewed in 3 dimensions to make sure the architectural features and layout make sense. 3D has even been used to help framers visualize the framing, an extremely valuable service. With stick framing, all the planning is done right on the job. This can lead to a framing process that does not always go as smoothly as expected. Headers may be installed upside down, and hangers may be forgotten. And the rafters spliced when not enough pieces are brought to the job site. These all happen to our stick frame house. This stick frame house was built to comply with the building code. Every connection detail was reviewed to make sure the engineering requirements were met. The code allowed connection loads of 198 pounds, while the engineered connection required 280 pounds. Every now and then, even the building code does not meet engineering requirements. Yet both structures pass the framing inspection. That's why you get superior craftsmanship through engineering and manufacturing. With engineering completed, the cutting list is downloaded to computer-controlled saws to accurately cut the component members. There is no guesswork involved at the saw, so thousands of truss members can be cut in one day. This leads to a precision fitting joint every time, assuring high-quality trusses. Watching the smooth and efficient truss assembly and manufacturing process, it's easy to see how an entire roof can be built very quickly in the factory. The same concepts also apply to the wall panel manufacturing process. Component parts are computer designed for each specific building. They're precision cut and fabricated to create a wall section that has the right number of connections in the proper locations. Again, it is craftsmanship through engineering and manufacturing. A quality house starts with a good foundation. The dimensions must be accurate and the walls plumb and square. If this isn't done well, structural and cosmetic problems may result. Now let's look at the floor framing process. In a stick-built floor joist system, the maximum length piece is about 16 feet. Each piece is inspected for the proper crown and set in the desired location. The joists are then set upright and toe-nailed to the foundation wall. Typically, joists are lapped in the center of the span and nailed. Solid blocking is inserted to add rigidity and stabilize the floor system. The final step is to lay down the flooring. Notice that the nailing surface is only 1.5 inches wide, so considerable care must be taken to be sure that all the nails hit the joist properly. Floor truss construction is different. Floor trusses are manufactured in long lengths, yet they're easy to carry and set. The spacing is typically 24 inches on center versus the traditional 16 inches for stick-built floors, so floor truss installation is much faster. Even blocking is easier to place and secure. The floor truss system is tied together using 2x4 band boards and inserting strong back bracing. Installing these properly enhances floor performance. The wide surface available for attaching the sheathing speeds gluing and helps assure accurate nailing. Construction of the component frame floor system required 26 fewer man-hours and used 1,100 board feet of lumber less than the stick frame floor.